Hello everyone, welcome back to OR2. On this video, we will continue our discussion on the network problem, and we will discuss the second problem in the network models, which is the max flow problem. We have a network over here, and it is a network of pipes. Sorry, there is a typo over here. It is a network of pipes. Okay, let me do this. Okay, it is a network of pipes carrying coal and connecting coal mines and a power plant. So the node are the coal mines, and the last node over here, the T, it is the power plant. We want to determine the maximum flow possible. Each pipe has its own capacity. So see the pipe connecting O and A, its capacity is 5, and the pipe connecting D and T, its capacity is 9. So our objective is to determine the maximum flow possible from O to T, from our source to our destination. Okay, now there is a conservation that we need to understand in the max flow problem. Number one, the total flow into a node equal to the total flow out of a node. Okay, so the total flow in must equal the total flow out. And then we may have forward arcs, and we may have also the backward arcs. So the forward arcs mean all arcs leaving a node, and backward arcs means all arcs entering a node. Okay, now the algorithm is what? It is very simple to determine the maximum flow in a network, and I will use the network of the pipes that we have over here to explain the concept of the max flow algorithm. So let me copy the network. Okay, I'm gonna copy it down over here. Let's see, I think I need some more space. Okay, this is the network that we will solve. Now the first thing that I need to do, I need to label f, the small f, in our original in our origin, and also f in our destination. So the small f labels the flow, and it is the it is the value of our objective function, and the value of f over here in our origin and the value of f here in our destination must be the same. Okay, now we can start from any path that we want. Okay, let's start from path from O. We can go to B, from B we can go to D, and from D we can do to T, and see how is the value of flow that we can have. See, from O to B we can have 7, from B to D we can have 4, and D to T we can have 9. Of course, we can only have 4 if we choose that path. Okay, so I'm gonna write it as, okay, here. Okay, I'm gonna make it smaller. Okay, so remember, so we can only have 4 because 4 is the minimum. So we have 4.7, which means the flow which means the flow that we have now is 4, but the capacity of the pipes is 7. And here we will have 4,4. So we use all its capacity, and here we have 4,9. And therefore, the amount of flow that we have now is 4. And here also, the amount of flow that we have now is also 4. Okay. The other path that we can also choose is we can go from O to A, and from A to D, and from D to T. See, we have 5 over here, we have 3, but here we don't have 9 anymore, but we only have 5 because we have 9 and we already use 4. Then we have 5 left. Okay, so 5, 3, and 5. So that means we can only use 3. Okay, so we use 3, so now we have 4, and then we add 3, so that means we have 7 over here. Okay, and here we have 5 and we use 3, so we're gonna have 3,5. Here we have 3,3, and here we have 7,9. And here also we have 4, we add 3, that means we have now 7. Okay, now step number 3. From O we can go to C, from C we can go to E, and from E we can go to T. See, so we have 4, 4, and 6. That means the amount of flow that we can have is only 4. So 4, we have now 7. So 7 plus 4, no, yes, 7 plus 4, that is 11. So we use 4. Okay, so we use 4,4. Here we have 4,4. And here we have 4,6. And 7 plus 4, and that is 11. Okay. Now, see that from O to A, we still have some amount of flow left, which is 2. So from O to A, but the only way that we can go to B, because we have not used the pipe connecting A and B. And from B, we can go to E, and from E, we can go to T, right? So here we have 2 left. We have 1, we have 5, and here we have 2 left. So we can only use 1. Okay, so we're gonna have 11 plus 1, that is 12. Okay, so here we add 1, so that means 4,5. Okay, and here we have 1,1, and here we have 1,5, and over here we have 5,6, and here we have 12 also. Okay, now, so from O we can go to B, from B we can go to E, and from E we can go to D, and from D we can go to T. So here we have 4 left, this is 3 left, this is 1, and this is 2 left. So we can only use 1. Okay, so here we have 5,7, and then I'm gonna have here 2,5. Okay, and here I have 1,1, and here I have 8,9, and here I have 13, and here also I will have 13. I think I forgot to put the capacity of pipe from B to C. It is 2. I need to do the black color. Okay, 2 over here, and I think I need to change. I need to put 2 over here. Okay, now let's see what we can do. So we still have 2 left from O to A, but we can go to D and we cannot go to B. We still have left from O to B. Okay, we can go to C. From C we cannot go anywhere because C2 is full. So the only thing that we can do, from O to B, we cannot go to D because BD is full. So we go to from O to B, from B to E, and from E to T, I think. So from O to B we have how many? We have 2 left. This is 3 left. And from E to T we have 1 left. 5, 6, that means 1 left. So we can only add 1. So we can only add 1. That means we have 14 over here. And here we have 6,7. Okay, here we have 3,5. Here we have 6,6. And here we have 14. And let's see, from O to A we can have flow, but from A we cannot go anywhere, right? Full and full. Okay, from A to D is full, from A to B is full. From O to B it is not full yet. We cannot go to D, it is full. We can go to E, but from E we cannot go anywhere because E to D is full and E to T is full. From B we can go to C, but from C we cannot go anywhere because from C to E it is full. Okay, from E we cannot go to C because it is already full. And I think this is it. So the total amount of flow that we can have is, so F optimal is 14. And the decision that we will have is, I'm just gonna copy it to label the decision. Okay, and let's see what we can have here. Okay, I'm just gonna copy it over here. Okay, I'm gonna, so the F, the decision, the F is 14. So F star is 14. So from O to A we have 4. Okay, so here we have 4. So the flow, it is here 4. From A to D we have 3. Okay, this is it. And from D to T we have 8. So it is 8. Okay, and then from O to B we have 6. Here we have 6. And then from B to D, we will have 4. That is it. From O to C, we have 4. And from C to E, we have 4. E to D, we have 1. E to T, we have 6. Okay. From B to E, we have 3. Here we have 5. So it should be 3. So 5 is its capacity, but the flow is 3. Okay. Let me see if we do this correctly. Oh, wait a minute. That's too small. Okay. Okay, let's see. 4, 6, 4. Okay. 1. Okay, there is no flow from B to C. So we will just erase it. So that's mean there is 0 flow, or we can just disconnect B and C. Okay, just disconnect B and C. Okay. The last thing that I need to do, I need to put this F star equal 14. Okay. Now we can check the solution by using what we call as the minimum cut. Okay, so we can cut the network anywhere we want, and then we can calculate the amount of flow that we have, the total of flow that we have in the cut. So let's do the cut over here. Just cut it over here. Okay. I'm gonna use a different color, I think. So just do a cut. Okay, this cut we have 4 flow. This cut we have 6 flow, and this cut we have 4 flow. 4 plus 6, 10 plus 4, 14. So we are good. Now let's do this cut. Okay. So here in this cut, 3, 4, 7, 7 plus 3, 10 plus 4, and that is 14. And now how if we do this cut? 8 plus 6, that is 14. How if we do this cut? Okay. So we're gonna have 3 plus 4, 7 plus 1, 8 plus 6, 14. So I think we are good. So I think this is the solution to the problem. So it is a quite simple algorithm. I think this is it for the maximal flow problem, and thank you very much.